video I will try to explain, we will derive the adder circuit using intuition. Like we will not go with the traditional approach, like we will draw the truth table and then k-map and derive the equations. We will just try to draw the circuit at logic level using the intuition. Okay, so what we mean by addition? By addition we mean that there is some particular number system. Let us suppose this is a decimal number system, and in decimal number system we have the possible digits as from 0 to 9, and it is a positional number system, means at every position whatever digit from this is present, like 0 to 9, based on the place value, it is value occurs in the particular number. Let us suppose we are having 1 9, so this 9 is occurring at 10 raised power 0 place, and this is occurring at 10 raised power 1 place. So the total value of this 19 in decimal number system is 10 plus 9 is equal to 19, means we are doing 9 multiplied by 10 raised power 0 plus 1 into 10 raised power 1, and this comes at 19. So in decimal number system 1 9 is equal to 19. Okay, so this 19 might not be like it can we have different value in different number system. Let us suppose we are having hexadecimal. In hexadecimal system we are having numbers from 0 to 9, and then A to F. So this is from 10 to 15, means we are having 0 to 15 possible unique values, and for every position, it is also positional number system. For every position we are having the base is 16. Okay, so this will be 16 raised power 0, this will be 16 raised power 1, and so on. So this 19 will be in hexadecimal number system. 1 multiplied by 16 plus 9 multiplied by 16 raised power 0. So this will be 16 plus 9, it is 25. So this same number 19 is in decimal number system, it is 19, and in hexadecimal number system it is 25. Okay, so we are considering here digital systems. Okay, so digital systems have their unique or we can say a different number system, that's called binary number system. Binary number system, and in this we are having possible values as 0 or 1, and it is a base or radix 2 system, means we are having two values in this system, and the possible values are 0 comma 1, and also it is a positional number system, means weighted. If we are having, let us suppose 101, this will be 2021 and 22. So the possible value of this number is 2 raised power 2 plus 2 raised power 1 plus 2 raised power 0, that is this is equal to 5. So this number in binary is 5. So now we come to the addition. So let us suppose we have to add this 1 and 6, and this is in decimal number system, and we do 1 plus 6 is 7. But in digital system or digital electronics, this 1 is not possible. We have to represent this 1 using the binary number system. And what is the possible largest value? This digital computer will work accordingly. The number of bits will be used for this. Let us suppose it supports up to maximum 10 digit values only. So means decimal value 10 can be represented, 11 cannot be, means up to 15 it can represent. So we are having 4 positions here. Okay, if we are having this will digital computer is able to represent 31 numbers, so we are having 5 bits here. If we are having only it can represent 0 or 1, so we are having only 1 bit here. If it can represent 4 possible values like 0, 1, 2 and 3, it can have 2 bits. So let us suppose we are having this 1 and 6, and what is the maximum number of bits we can represent here? So maximum value is 6, so we will do log of 6 is equal to, so we have to do max. Okay, so this will be the seal value, so it will be 3. So 3 bits we will be utilizing for representing both the numbers. So this 1 will be here 0, 0, 1, and this 6 will be here 1, 1 and 0. So now we have to add this 0, 0, 1 and 1, 1, 0 using the digital electronics. And in digital electronics we don't have any such thing as plus or something minus, like we press the plus button and we got the addition of these numbers. Okay, so then what are the possible operations? Like, you know, in decimal number system we say that we have plus, minus and other operations, but in this digital electronics works on boolean uh, boolean algebra or boolean we can say boolean logic. So it has only 3 possible possible operations. It has only 3 possible operations. So what are those are plus, minus and the sorry those are and, or and not. These are also called the universal gates or logic. Why? Because with this only 3 operations whole digital circuits work, or we can say uh, all of the operations like plus, minus, subtract and all those things can be implemented using these 3 gates only. Okay, so now what we have to do, we have 2 numbers here. We have to perform the addition of these 2 numbers. So we are having only 3 logic available. That's, let us suppose we are having this and it is, we are having here 2 values. Let us say it is as a and this is b. Properly saying as we have a2, a1, a0 and b3, b2, b1 and b0. This is 0, 0, 1, this is 1, 1, 0, and we have to perform the addition of these numbers. And as we are having here 2 inputs, we will say 2 input AND gate. Let us say is that it has a not and b not. What this AND gate says, that it says that this a is a binary variable. It can have 2 values. It can have 2 values, 0 or 1. This can have 0 or 1. So the possibilities are, this can be 0, okay, and this can be 0, this can be 0, and now this is 1, because for it has having this has evaluated 1 time, this has evaluated 2 times. Now this can be 1 and this can be 1, and this is 0 and 1. So accordingly we have evaluated, basically what we are saying that a and b, this can be 0 or 1, this can be 0 or 1. So if we combine that, it is 0, 0, then it is 0, 1, then it is 1, 0, and then it is 1, 1, 1. So these are 4 possibilities. So the output with this AND gate will be, if both the inputs are 0, 0, output is 0, 0 and 1. Means if both the inputs are 1, the output is 1. This is AND logic. Another one is OR logic, which says that if we are having A0 and B0 and the output we want to know, so accordingly we are having 2 bits, so 4 values are here, 0, 0, 0, 1, 1, 0 and 1, 1. And what it says that OR logic, it says that if any of the inputs are 1, the output is 1. So here both the inputs are 0, the output is 0. Here 1, 1 and 1, because if any, here any means anyone, so it here both, so still the output will be 1. So this is the OR logic. So another is NOT logic, which says that it is only one input based. Let us suppose we are having A naught or B naught. If it is 0 or 1, the output will be 1 or 0, means if our input is 0, output will be 1. If input is 1, output will be 0. Now we have to perform the addition of these numbers. Okay, we have to perform the addition of these numbers, matlab 0 1. So what we want here, this is 1, means it is 1 in binary, because 2 raised power 0 multiplied by 1 is equal to 1. So this is 1, and this is 2 raised power 0 multiplied by 0, it is 0. So 1 plus 0 should be 1. This is the summation operation. It says us it should be 1. So let us write here 1. So now what type of gate we are having here? 3 type of gate or 3 type of logic. What type of logic will give us this 1 0? The output should be 1. What type of logic? So 1 0 should be 1. This is giving us 1 0 output. So should we use OR logic here? We have to check other possibilities as well. Okay, because this says also this, or if we do A naught or B naught is equal to sum, we say that A naught or B naught sum 0, but it is incorrect, because if we see this OR logic, if we are having both input 1 and 1, the output will be 1. So if we now see, if we are having A naught equal to 1, B naught equal to 1, so this means the output will be 1 1, it will be 1 0. Why? Because this is 1 plus 1 is equal to 2. So this is 2, this is 2 raised power 1, this is 2 raised power 0. So 2 is this value. So but means here we should get 0. If we are having both inputs A and B as 1, the output should be here 0. But if we use this OR logic, this will be wrong. It will, for this possibility 1 0, it is giving correct value, but for this value it will give incorrect value. So we have to think other ways. So what we can do, we say that okay, we say that what basically we want, we say that if A naught B naught is 0 0 0 1 1 0 1 1, and we want the sum, so sum should be here 0 1 1 and 1. So and another thing, we need carry, means we see here that we have got the carry here, and it has moved to the next position. So carry logic also we require. So carry will be here 0 0 1, carry will be 0 1 0, carry will be 0 1 1, carry will be 1. So if we see here, this thing, this type of, it is reminding us AND logic. So straight away we can use for carry A naught dot B naught, means AND logic will give us the carry. So carry is done. Now what? Sum. Okay, so but here I have done wrong, like here it is output is 0, because 1 1 will be 1 0, so sum will be 0, means at that particular position, and the carry will go to the next position. So it says that this is no logic, neither not or NAND, neither of these is able to fulfill this condition. So we have to concatenate the operations. So we say that this is A naught, means it is 0, we say that A naught, it will give us 1, means this is 0 0 naught will give us 1. We say that this is 1, so this is B naught, so 1 dot, this is 1 already, so it will give us 1, so output is 1. Or this is A naught, means it will not be naughted because it is already 1, so dot, and B naught is 0. If we do here B naught directly, so it will be 0. We want here 1, so we have to put naught here. So this will be now 1 dot 1, and it will be, output will be 1. And for, if we check for this possibility, 0 dot 0 naught means 1 dot 0 means 0, so it will be fulfilled. And if we see this will also be fulfilled. So means now we have represented sum is equal to a naught dot b naught plus a naught dot b naught. So this is also given a specific name as XOR operation. So we have came to know with intuition that for carry generation, for two input bits, say a naught comma b naught, we will use a naught dot b naught and logic. And for some generation, using digital logic, of course. So we don't have any specific, directly we can put the logic there. We have to concatenate some operations. So we will see that a naught dot b naught plus a naught dot b naught, and here we see that this is 0 and 1 and 1 0 means any one of the two inputs is 1 and any one of the input is 1. Okay, so the output will be 1 in those two cases, otherwise it will be 0, and here the output will be 1 when both the inputs are 1. So this gives us the two input sum logic, that is also given a name as half adder. And next, full adder, that we will discuss in the next. Okay, so that's for it.